Здравствуйте.
My presentation is about developing of the new graphic models for computer network visualization. Let us just enter the world of visualization, so you will see these models. First of all, there is a representation of a computer network and the cases that we'll be using. There are three cases here: attacks, topologies, metrics. It will be more than enough. How do we visualize the attacks? So on the right hand side there is a matrix which is showing the attacks. We have hosts here and the vulnerabilities which allow the hacker to do these attacks. So exploiting this vulnerability, it leads the hacker to a new host. In sub-network number 2 you can move to another one, yet another one, so it is higher than diagonal. We're moving forward and we're moving backward. Dissipation path, source and destinations and ports. If we scan one machine, many ports, it's a line and a plane. So you can visualize this scanning pattern. On the right hand side you have parallel coordinates, sources, destinations, and the scanning is seen easily. How do we visualize the metrics? You can add glyphs to it. So here is a circle, the current scanning result. The left hand side, the right hand side denote the vulnerability with the which equals 9. The outer part is a result of the previous scanning, a typical state of the network, and the matrix does not allow us to visualize the host metrics, but we can highlight them with color, transparency. We do the clusterization so that we can see the cells, the structures, which help us understand what this network is all about. One of the most effective ways to visualize the metrics is given here, because it's spatial. We have a router to which the hosts are connected. We have this rectangular with hosts. So an orange one is a router. Inside there are plenty of routers, etc., etc. So one router with one host. Typology. Graph is the simplest way because it's intuitively clear. If you need to project a few hierarchies and topologies, you just use this visualization like it's on the right with hosts, and then they are combined, and then they combined again. What's linked here, what's related to where, is marked with a color, with the direct lines, curves, etc. And it can be expanded in the shape of a tree. Well, it's all good, but it seems like that we have three base concepts upon which these models are based. What are the concepts? The first one is the overlapping concept. For example, we have coordinates and even the simplest graph with a sinusoid demonstrate that. The tree map and the graph with the connections. We have some graphic elements. So So what's developed for new graphic models? What is the trend in visualization? First of all, the work with data, the clusterization of hosts. When we single out what is required, and encapsulation, when we connect all of the hosts together. So these two graphs is actually one. The next one is design. We have realized finally that the design is not effective only in marketing, but it's very good for visualization. As far as we can see, here is a trend for the variable design, minimal design, etc. And the interactive part. Through the interactive part, the user is operating with the data through graphics and not directly. It looks good, but all of these models, the concept, have deficiencies and they coexist. Therefore, the graphs have plenty of free time and free space. They poorly visualize the metrics. The trees can only be shown in the hierarchy, and the matrices they also leave quite a lot of space. And our solution here is to use a new concept based upon collisions. So let us imagine it's our host, is our cell, and we have a connection with the hosts. If the cells have no connection, we put a separator here.
Простая аналогия, лабиринт. То есть представьте, что...
For example, you are in a labyrinth, in a maze. You can move from one room to another. First, plenary approach. Then we have the Delon modulation. For example, imagine these are the nails, we put them in a board. We apply the Delon triangulation, keeping the structure, the previous intact structure. Then we single out the sails and the diagrams. It turns out that out of the triangulation we'll be using the model here, and we can identify the host, the triangles, the centers, and we have approximately this structure: triangulation and the graphic model. We show the separators and the deficiency. We can only apply it to plenary networks. Let's just take a look at the advantages. We'll be comparing it to the graphs. In our model, we'll be showing the size of the cell, and the vulnerabilities are here. What does it look like? Here. Let's compare. Just through spatial aspects, you perceive it in a better way. You need to have special cases where you can apply it to. It's a concept based upon we can expand it further on. For example, if we make a section out of it, we will have a prism. Then we can come up with different representations. We can show it in forms of cells and lines. The next one, we can put in different values, and we do not consider our graphic model only as one for visualization of the computer networks, but also for visualization of other processes. And in the end, I would like to say that the graphic models are the ones that we exploit most of. We use design, we use these concepts. And basically, I think that our developments will help us move forward. Thank you very much.
Вопросы, если есть. Давайте
У меня такой вопрос. А вы пытались как-нибудь визуализировать?
Did you try and visualize the formats so that it would have a very nice and sleek representation? We try to do it for students, and it seems like that you did not perceive quite right. It was very hard to perceive. Did you have such experience of visualizing data structures? In particular, I'm in charge of the visualization of the computer networks that can be in the future applied to the monitoring solutions. But you can do something to visualize the formats, the security formats.
Итак, давайте поблагодарим Максима за доклад.
Thank you, Maxim.